Let's be entirely honest for a second. If you've ever opened up an IGCSE Maths 0580 paper, stared at a massive, chaotic jumble of algebraic equations, and felt a wave of absolute panic wash over you, you are definitely not alone. It's overwhelming. But here's the secret that top-tier students know. You don't have to fight the algebra head-on. Today, we are going to learn how to act like an alchemist. We are going to transform those complex, intimidating numbers and letters into a visual language. We're talking about clear, predictable shapes that will dramatically speed up your problem solving and basically hack the exam. Welcome to The Explainer. I'm going to be your strategist today, and we are decoding graphs of functions so you can lock in those maximum marks.
Here is our strategic roadmap for today. We'll start with the family of functions, move into quadratics, tackle reciprocals and exponentials, learn how to solve equations purely visually, and finally, master the ultimate exam cheat code, the art of sketching. Section 1. The family of functions. Let's get to know the key players.
To become a master visual translator, we first need to meet our core cast of characters. In the Cambridge 0580 syllabus, so many common graphs are governed by one incredibly simple rule: x to the power of n. Listen closely, because simply changing the value of n completely transforms the physical landscape of your graph. It's like flipping a switch. When n is 1, you get a straightforward linear function. It's just a straight line, no surprises. But bump n up to 2? That rigid line bends into a smooth quadratic parabola. Make n equal to 3, and suddenly you have a cubic curve, slithering across the page with multiple bends. And if you make it a -1, the entire graph fractures into a reciprocal hyperbola. Knowing these base shapes is absolutely crucial. It means you instantly know what an equation is supposed to look like before your pencil even touches the paper. You're anticipating the answer, not just reacting to the question.
Section 2. Quadratics and turning points. This is where the heavy lifting happens.
Our first major shape is arguably the absolute most important one for your exams, the quadratic function, where the highest power of x is squared. This produces a beautifully smooth, perfectly symmetrical curve called a parabola. Now, here is a brilliant, quick visual check that saves students from silly, grade-dropping mistakes all the time. Look at the x squared term. Is it positive? If so, you get a classic U shape. Think of it as a smile. Positive equals happy. But if the x squared term is negative, the whole graph flips into an upside-down U, a frown. Negative equals sad. It's a tiny detail, but checking that before you plot anything guarantees you are moving in the right direction.
Now, because of that U shape, every single parabola naturally has a peak or a valley. We call this the turning point. It's either the absolute maximum point of an inverted U or the minimum point of a regular U. The curve goes down, stops, and turns back up. Finding the exact coordinates of this turning point is a massive part of the IGCSE exam. Examiners absolutely love testing your efficiency here. They want to see if you know the quick way or if you're going to waste precious minutes doing it the long way.
And here is that quick way. By rearranging your quadratic into the completed square form, you can instantly read the turning point without plotting a single dot on a grid. If you can get your equation into the format y equals a times x minus b squared plus c, the coordinates of your turning point are simply b, c. Let that sink in. For example, if you rearrange your algebra and end up with y equals x minus 5 squared plus 2, your turning point is exactly at the coordinates 5, 2. Boom! No complex calculations, no guessing, you just pull the numbers straight out of the brackets. Before we continue on to some of the more bizarre graphs, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. You do not want to miss the strategies we drop every single week.
Section 3. Reciprocals and exponentials. These are the unique, rule-breaking functions. These unique functions behave very, very differently from those smooth, continuous parabolas we just talked about. For reciprocal functions, like y equals 1 over x, we have to introduce a fascinating, almost mind-bending concept called an asymptote. Think of an asymptote as an invisible, high-voltage electric fence. As the values of x get really, really large, the graph plunges down and gets closer and closer to the x-axis, but it never, ever actually touches it. And as x gets closer to 0, the graph shoots straight up or straight down, getting infinitely close to the y-axis, but again, never crossing it. These invisible walls physically split the graph into separate pieces, creating what we call a hyperbola. It looks intimidating, but once you spot where the electric fences are, drawing the curves becomes incredibly easy. Then we have exponential functions, taking the form y equals a to the power of x. These are the graphs of rapid extremes. explosive growth, or sudden decay. But here is a fascinating anchor point for every single one of these graphs: the coordinate 0, 1. Why? Because a fundamental rule of math dictates that any non-zero number raised to the power of 0 simply equals 1. So every single standard exponential graph crosses the y-axis at exactly 1. Whether the equation is 2 to the power of x or a massive 400 to the power of x, they all inevitably pit it through that exact same anchor point before rocketing upwards. It's a guaranteed free mark if you remember it.
Section 4. Solving equations visually. This is where we turn shapes back into answers. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, now that we know our shapes, let's unlock their absolute superpower. Imagine you are sitting in the exam hall, the clock is ticking, and you are hit with this: x cubed plus x minus 2 equals 0. Finding the roots for a cubic equation algebraically, that looks incredibly intimidating. Honestly, it could take you ages, and the risk of making a sign error is huge. But graphically, this exact same problem becomes so incredibly straightforward, it almost feels like cheating.
Think about it. If you have already plotted the curve for y equals x cubed plus x minus 2 in a previous part of the question, which Cambridge loves to make you do not need to do any more math. You literally just need to use your eyes. Look at the graph you just drew and find exactly where that curve slices through the horizontal x-axis. Why does this work? Because the x-axis is literally the line where y equals 0. So where the curve hits that line, the whole equation equals 0. The x-coordinates at those intersection points are your actual solutions. They're just sitting right there on the paper waiting for you to read them off the grid.
But what if the examiner decides to get sneaky and throws a variation at you? Let's say you plotted y equals 3x squared minus 2x, but then part B asks you to solve 3x squared minus x minus 5 equals 0. A lot of students panic here and try to draw a whole new complicated graph. Do not do that. Just manipulate the new equation to perfectly match your original curve on one side. By simply rearranging the algebra, moving some terms to the other side of the equal sign, you'll end up needing to find where your existing curve crosses a super simple straight line, like y equals negative x plus 5. All you have to do is draw that one straight line with a ruler over your existing graph. The exact points where the straight line and the curve intersect, those are your answers. It takes seconds and it bypasses pages of painful algebra.
Let's quickly look at how this builds into deeper concepts, like finding the gradient. A straight line is easy. It has a constant slope. But a curve? Its slope is constantly bending and changing every millimeter. So to find the gradient of a curve at one highly specific point, we have to freeze it. We take a ruler and draw a straight tangent line that just barely grazes the outside of the curve at that exact point. It shouldn't cut through the curve, just kiss the edge of it. Then you calculate the gradient of that straight tangent line using the standard rise over run formula, y2 minus y1 over x2 minus x1. Because the tangent perfectly matches the steepness of the curve at that exact moment, the gradient of the tangent is the gradient of the curve. Simple, elegant, and highly effective.
Section 5. The Art of Sketching. This is how you reclaim your time in the exam.
For our final act today, we are transitioning from tedious calculation to the highly efficient art of sketching. Look at this table of values. Plotting every single coordinate point exactly, calculating y for x equals -4, then -3, then -2. It is exact, yes, but it consumes so much precious time. If a question specifically uses the command word sketch rather than plot, and you start drawing a table of values like this, you are falling into a massive time trap. You are wasting your exam clock on precision that the examiner didn't even ask for.
Here is the golden rule you must remember. Plotting requires exactness across every single point on the grid. Sketching only requires the mathematical highlights. A sketch just needs to show the overall general shape of the function, and the critical points where something mathematically important happens, like crossing an axis. Why on earth would you spend 5 or 6 minutes painstakingly calculating and plotting 10 separate dots, when a 30-second fluid sketch gives the examiner the exact same mathematical insights? They are testing your knowledge of the function's behavior, not your ability to connect the dots.
To master this art, you literally just need this 4-step checklist. Write this down. First, plug in x equals 0. That instantly gives you your y-axis intercept. Second, set y to 0 and solve the equation to find exactly where it crosses the x-axis. Third, look at the highest power in the equation to know the general shape. Are we drawing a U, an inverted U, a cubic snake, or a fractured hyperbola? And finally, if it's a quadratic, use the completed square method we talked about earlier to find that turning point. If you follow this exact checklist, you'll be able to confidently sketch almost any linear, quadratic, or cubic function in seconds and grab maximum marks every single time. And remember, students who implement these exact strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
We have covered an incredible amount of ground today, from the basic family of functions all the way up to the time-saving power of rapid sketching. But take a step back and think about what we are actually doing here. We are taking abstract, confusing, complex rules and translating them into clear, beautiful pictures. By mastering these visual tools, you are not just passing your IGCSE exam, you are learning how to see the simple solutions hidden behind messy numbers. So I want to leave you with a thought. If a quick sketch can reveal the true nature of an intimidating equation so effortlessly, what other difficult problems could you solve just by stepping back and looking at the bigger, visual picture? Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep practicing, keep sketching, and I will see you next time.